For as long as human beings have owned telescopes powerful enough to see it, there has been an eye on Jupiter, a red, unblinking wound in the clouds of the largest planet in the solar system. A storm wide enough to swallow the Earth whole and keep spinning as if nothing had happened. It has outlasted empires, revolutions, and every person who has ever pointed a lens at it. Today, that eye is closing. This is not a simulation, and it is not a hypothesis. It is a measurement repeated for 150 years by astronomers who had no idea what they were recording. The Great Red Spot is shrinking in real time, and the shrinking is speeding up. There is a serious chance that we are the last generation of human beings who will ever see it alive. So why has the most stubborn storm we have ever found started tearing off pieces of itself right now? What happens to an entire planet when its greatest engine finally stops? And why do a handful of scientists insist that everything you are about to hear about its death is wrong? Start with the numbers, because the numbers are what turned a curiosity into an obituary. In 1879, astronomers with the best instruments of their age measured the Great Red Spot across its longest axis. They recorded roughly 24,000 miles. At that size, you could line up 3 Earths inside it, side by side, and still have room to spare. It was not a feature on the planet. It was practically a second planet pinned onto the first. A century later, in 1979, the Voyager spacecraft arrived and photographed it from close range for the first time. The storm had lost nearly half its length. Then Hubble kept watching, decade after decade, and the number kept falling. By the 2020s, the spot had come down to about 8,700 miles, which is barely wider than the Earth. 3 Earths became 1. The shape has been changing too, and that detail matters more than it sounds. For as long as we have records, the spot was a long, elegant oval, stretched east to west by the winds around it. It's now close to a circle. Something that was once pulled wide is being squeezed in. And the decline is not gentle. Since roughly 2012, the rate of loss has accelerated sharply, with the storm giving up hundreds of miles of width every single year. If you were somehow able to watch Jupiter for a human lifetime through the same telescope, you would see it visibly close, like a wound healing over. Which raises the obvious question: how did a storm this violent survive as long as it did in the first place? One quick thing before the answer. If this is your kind of story, subscribe and tap the bell so the next one finds you. On Earth, a hurricane is a temporary thing. It gathers strength over warm ocean water, spins for a week or two at most, and then crosses a coastline and dies. The reason is simple. It runs into the ground. Mountains, forests, cities, and plain, rough terrain all drag against the base of the storm and tear it apart from below. Jupiter has no ground. There is no surface anywhere on that planet. No continent, no coastline, nothing solid to make landfall on. Descend into Jupiter and the air simply grows thicker and hotter and heavier until it stops behaving like a gas at all, with no boundary in between. A storm born in that atmosphere has nothing to crash into. It can spin in principle forever. The second reason is the way the planet moves. Jupiter is wrapped in bands of wind racing in alternate directions, an enormous striped machine of jet streams running east and west. The Great Red Spot sits wedged between 2 of them, with one belt of wind dragging along its northern edge and another hauling in the opposite direction along its southern edge. Think of a marble caught between 2 conveyor belts running opposite ways. The belts don't crush the marble. They spin it endlessly, and the spinning is fed from both sides at once. This is the Great Red Spot. The storm is not fighting the winds of Jupiter. It's being wound up by them, like a top that never has to be touched again. Then there is the feeding. Jupiter's atmosphere is crowded with smaller storms, and when one of them drifts too close, the Great Red Spot pulls it in and absorbs its energy. For centuries, it has been the bully of that latitude, growing fat on the smaller vortices that wandered into reach. And the violence inside is difficult to convey. Winds along the rim tear around at more than 250 miles per hour, faster than any tornado ever measured on Earth, And the storm is so vast that a parcel of air caught in that current needs roughly 6 days to travel once around the edge. 6 days at hurricane speed to complete a single lap. Drop into the middle of it and there is no eye of calm waiting, no coastline to make for, just an endless red twilight of ammonia cloud lit from below by lightning, with nothing solid beneath you for thousands of miles. But the strangest fact about this monster surfaced only recently, and it came as a genuine shock. In 2017, the Juno spacecraft flew over the spot with an instrument that could see beneath the cloud tops, and it measured how deep the storm actually goes. The answer came back at roughly 200 to 300 miles. That sounds enormous, and in human terms, the figure is staggering. But set that against the width. The storm runs nearly 9,000 miles across and only a couple hundred deep, roughly 50 times wider than tall. Our most famous storm is not a towering column at all. It is a coin, a vast, spinning wafer of cloud lying flat across the face of a planet. And a coin, as we are about to see, is a fragile shape to be. So a storm with no ground to kill it, wound up by two opposing rivers of wind, feeding on everything that comes near, should have been immortal. Something has changed. In the last few years, the Great Red Spot has started behaving in ways nobody predicted and nobody can yet explain. And two separate discoveries have astronomers watching it now with the attention normally reserved for a patient in decline. The first sign arrived in the spring of 2019, and it was spotted by amateurs before the professionals caught up. Watching the eastern edge of the storm, observers saw enormous blades of red material peeling away from the main body, curling outward into the surrounding clouds and dissolving. Then it happened again and again. Over several months, the spot repeatedly shed huge red flakes, each one carrying away a piece of the vortex, or at least a piece of something. Nothing quite like that had been recorded with such clarity before. Watching those images in sequence is genuinely unsettling, because the storm looks like it's coming apart at the seams, throwing off fragments the size of continents. The second sign came from Hubble, and it's stranger still. Between December 2023 and March 2024, astronomers pointed the telescope at the Great Red Spot and did what no one had managed properly before. They watched the storm continuously at high resolution across an entire 90-day stretch, tracking size, shape, color, and speed. What they found was a rhythm no one knew existed. The storm is oscillating. Over a 90-day cycle, the spot squeezes inward and then swells back out, turning narrower and rounder while accelerating, then wider and more oval as the motion slows. The team described the effect as jiggling like a bowl of gelatin and compared the storm to a stress ball being repeatedly squeezed. Then came the part that made the result newsworthy. Nobody knows why. The scientist who found it stated plainly that there is currently no fluid dynamics explanation for the behavior. The most closely studied weather system beyond Earth, watched for nearly 200 years, is doing something rhythmic and enormous that our physics did not anticipate and cannot yet account for. One clue may lie in those jet streams. As the spot accelerates and decelerates, it is shoving against the rivers of wind running past it on both sides. The storm and the planet are pushing on each other, and something in that struggle appears to be beating like a slow pulse. What it means for the future of the spot, nobody can say. And this is exactly where the story gets complicated, because not everyone agrees the patient is dying at all. There is a serious objection to everything you have just heard, and it deserves to be taken seriously, because it comes from people who have spent careers modeling this storm. The objection is this: we've never actually seen the Great Red Spot. Not once. What we see in every photograph ever taken from every telescope and every spacecraft is the cloud deck sitting on top of it. The vortex itself, the spinning body of fluid that drives everything, is buried below and invisible. We are looking at the lid, not the pot. Under that reading, the shrinking red oval may be telling us about the clouds rather than about the storm. Some researchers argue there is no clear evidence that the vortex underneath has weakened at all. The flaking in 2019, in their view, is not the storm disintegrating. It is the storm shedding cloud material it never fully absorbed, torn away as it grinds past certain points in the surrounding flow. One of the leading modelers of Jovian vortices put it bluntly, borrowing an old line, saying that reports of its death have been greatly exaggerated. Even the teams tracking the shrinkage most closely are careful about what they predict. The long-running Hubble program that has monitored it for over a decade expects the spot to keep contracting for a while and then settle into a smaller, rounder, stable form rather than vanishing outright. So the honest position is uncomfortable and far more interesting than a clean death sentence. Something visible and dramatic is happening to the most famous storm we know of. The pace has quickened, and the people who understand it best are openly divided about whether this is an ending or a transformation. But there is one piece of evidence that leans hard toward the darker reading, and it was uncovered only recently, hidden inside 400-year-old drawings. In the 1660s, the astronomer Giovanni Cassini turned his telescope on Jupiter and recorded a dark oval sitting in the planet's southern hemisphere. He and others followed it faithfully for decades and gave it a confident name. They called it the permanent spot. Then in 1713, it was gone. The observations simply stopped. For the next 118 years, astronomers looked at Jupiter and saw nothing at that latitude worth drawing. Only in 1831 did a spot reappear in the sketches, growing more prominent through the following decades until it became the feature we photograph today. For centuries, everyone assumed these were the same storm, briefly lost during a gap in careful observation. In 2024, a team of planetary scientists tested that assumption properly, measuring sizes, positions, and drift rates from the original historical drawings, and comparing them against everything we know about how such vortices move. Their conclusion was that the two are almost certainly not the same storm. Cassini's permanent spot appears to have genuinely died sometime in the 18th or early 19th century, and the Great Red Spot we know is a separate vortex that formed afterward. It's not 3.5 centuries old. It's closer to 200, which still makes it the longest-lived storm ever recorded anywhere by an enormous margin. And now the detail that should raise the hair on your arms. When researchers worked out how large the permanent spot was in its final years, before it disappeared from the record, the answer was small, roughly the size the Great Red Spot has shrunk down to right now. Jupiter, it seems, has done this before. A giant storm at that latitude grew, dominated the planet for generations, contracted past some critical size, and then unraveled completely. If that is what we are watching for a second time, then the shrinking is not a curiosity. It's a countdown, and we may already be inside the final stretch of it. Which leads to a question that rarely gets asked. What does Jupiter actually lose when the spot goes? The answer may be far bigger than one missing landmark, because of a discovery that had nothing to do with the storm's size. Jupiter has an old and embarrassing problem in planetary science, sometimes called its energy crisis. The upper reaches of its atmosphere are hundreds of degrees hotter than they have any right to be. Jupiter sits 5 times farther from the sun than we do, receiving a fraction of the sunlight, and yet its upper atmosphere runs at temperatures you would expect much closer in. For decades, nobody could account for the missing heat. Then, in 2016, researchers mapped the heat across the entire planet in infrared, hunting for anomalies. They found one, sitting directly above the Great Red Spot, several hundred miles over the top of it, was the single hottest region in Jupiter's upper atmosphere. The explanation is beautiful. The turbulence inside the storm is so violent that it launches waves upward through the atmosphere, both sound waves and slower rolling waves in the air itself. Those waves travel hundreds of miles up, and when they arrive, they break, in the same way ocean swells break on a beach, dumping their energy as heat. The storm's not merely a feature sitting on Jupiter. It may be one of the furnaces heating the sky above it, a radiator wired into the climate of the entire planet. If the spot fades, that furnace fades with it. Nobody can yet say how much of Jupiter's mysterious warmth depends on it, but a planet losing one of its major energy sources is not a cosmetic change. There is also an heir apparent, and its story is a warning in itself. Beginning in 1998, 3 white oval storms in the southern hemisphere drifted together and merged, one collision after another, until by the year 2000 they had become a single vortex. Astronomers labeled it Oval BA. Then, in late 2005, something happened that nobody had ever witnessed before. It began to change color, and within months the newly merged storm had turned red. The press named it Red Spot Jr. It's roughly half the diameter of its famous Elder and still large enough to hold the entire Earth inside it. For the first time in recorded history, humanity watched a red spot on Jupiter being born, and we may be about to watch the other one end, which means we could be living through the single generation that sees both. Stand back from the arguments and the measurements, and what remains is a strange kind of privilege. Every human being who ever looked at Jupiter, from Cassini with his hand-drawn sketches to the crowds who queued at observatories in the 19th century, saw a planet with a red eye. It was simply what Jupiter looked like, permanent in the way mountains feel permanent. It never occurred to most of them that they were watching something with a lifespan. We now know better, and knowing better costs something. The storm is smaller than when your grandparents were born, smaller than when the Voyager probes flew past, measurably smaller than a decade ago. Whether it dissolves entirely or shrinks into some stable little knot of red, the Jupiter that stares back at us through a backyard telescope is not the Jupiter our ancestors saw, and it is not the one our grandchildren will see either. Nothing out there is fixed. Not the storms, not the planets, not the stars. Most of it simply moves too slowly or sits too far away for us to notice in a single life. Once in a while, the universe slows down enough to let us watch a genuine ending, and this is one of them. Point a telescope at Jupiter this year. That red eye has been open longer than any storm ever recorded, and it will not be open forever. And if watching the sky change while we happen to be here does something to you, there's a whole list of cosmic events already scheduled, sights so rare you'll only catch a handful of them in an entire lifetime. We counted them down in our end screen video. Watch that one next.